Somewhere in this galaxy right now, there is a planet about the size of Earth falling through the dark with no sun to fall around. It has no year because it circles nothing. Its surface is hundreds of degrees below freezing, and it has been that cold, and that alone, for longer than our species has had a name. There are billions of these worlds, maybe more of them than there are stars, and every one of them is a planet that left home and never found another one. I bring this up because of a story we like to tell ourselves. In it, the Earth finally dies, and the last of us are not there for the ending. We are already gone, sealed inside a great ship, sailing outward to find a new world. It is a comforting story. Tonight I want to take it seriously and follow that ship out past the last planet into the space between the stars and ask the question the story never does. If Earth is behind us and no new world is in reach, how long can the last humans actually last? Tonight, we are going to take that ship all the way out and find out what actually happens to it. By the end of this, you will understand why there is almost certainly no new world close enough to matter, why going slow kills the ship and going fast kills the crew, and what the space between the stars would really do to a sealed machine trying to cross it. I am not going to soften the answer, because the answer is more interesting than the comfortable version. Some of this is genuinely unsettled, and I will tell you exactly where the science runs out and the guessing begins. If these late-night walks out into the dark are the kind of thing you enjoy, a quick subscribe helps more of them find you. Now, let us begin. The last world you ever pass is not the one you launch from. The one that truly marks the edge sits far out at the rim of our own family of worlds, out where the sun has shrunk to a point you could hide behind a raised thumb. Neptune, a cold blue world about 4.5 billion kilometers from the sun, so far out that full daylight there is dimmer than the last grey minute of dusk. If you were standing on a moon of Neptune, the sun would be the brightest star in the sky and almost nothing more, a hard white spark giving almost no heat. And here is the first thing the escape story gets wrong. Neptune is nowhere near the edge. It only feels like one. Beyond Neptune, the sun's family does not stop so much as thin out. There is a scattered belt of frozen bodies past its orbit, lumps of ice and rock left over from the making of the planets, and then even those grow sparse, and the ship carrying the last of us keeps going into a place that has fewer and fewer worlds in it. For a long time the sun still holds a kind of grip out here, not through raw gravity so much as through its breath. The sun blows a constant thin wind of charged particles outward in every direction, and that wind carves a great bubble around the whole solar system. The edge of that bubble, where the solar wind finally slows and stalls and the pressure of the space between the stars pushes back, has a name: the heliopause. That is the boundary of the sun's weather, the place where the sun stops being a wind and becomes only a light. We know exactly how far away that boundary is, because something of ours has crossed it. A small craft launched more than 40 years ago, built to fly past the giant planets and then simply keep going, finally pushed through the heliopause and out into true interstellar space after 35 years of flight. That was the first object human hands ever made to leave the sun's bubble entirely. And I want you to sit with what that actually means, because it is the quiet fact that breaks the whole comfortable picture. That craft is moving at about 17 kilometers every second, not 17 an hour, 17 every second, faster than anything with people aboard has ever traveled, fast enough to cross the whole width of a country between two breaths. It has been running at that speed for the better part of half a century, and it has only just cleared the doorstep. There is a cruel little detail to that craft too, and it belongs to this story more than it might seem. Its power comes from a slowly decaying lump of plutonium, and that lump gives a little less warmth and a little less electricity every year, so that one by one its instruments have had to be switched off to save what remains. It is dying by inches out there, going quiet and cold in stages, still calling home but with a fading voice, on a trickle of power that will run out entirely before very long. Even our most successful ambassador to the dark is winding down. Remember that. It matters later, more than you would think. Because here is the distance nobody in the escape story wants to say out loud. If that craft were pointed straight at the nearest star to the Sun, and it kept going at that same 17 kilometers a second, it would arrive in a little over 70,000 years. Not 70 years, not 700, 70,000. The fastest thing we have ever flung out of the solar system would need more time to reach the closest star than our whole species has so far existed, several times over. Every human face that has ever lived, every language ever spoken, the whole of what we call history, all of it fits many times inside the wait for a single one-way crossing at the fastest speed we have got. And even the heliopause is not really the end of the Sun's reach. Far beyond it, out in the true dark, there is thought to lie a great faint shell of frozen comets, the Oort cloud, loosely held by the Sun's gravity in numbers beyond counting. That shell may stretch outward as much as a quarter of the way to the nearest star, perhaps even further, which means that the Sun's real gravitational territory, its true outermost edge, does not end at the heliopause at all. It reaches nearly a light year out, an enormous hollow sphere of dark ice, and a ship would still be crossing the Sun's own faint outskirts for thousands of years after it left the last planet behind. The solar system does not have a wall. It has a fade, and the fade goes on almost all the way to the next star. On its slow way out through all of this, the ship would pass the small frozen worlds that live in the Sun's far reaches, places like Pluto, dim and distant, and the little double-lobed lump of ancient ice called Arakoth that one of our probes has already coasted past out there in the deep cold. Each of them is a frozen relic barely touched by a sun that has dwindled to just another bright star, and each is the last solid ground of home the ship will ever see. After the last of them there is nothing underfoot at all, not for tens of thousands of years. The ship trades away the final real worlds of its own family for an emptiness in which the next solid place it could ever stand is 4 light years and 1,000 human lifetimes off. That is the true meaning of leaving. Not a bold step out onto open road, but the closing of the last door behind you, with the next door too far ahead to see. And notice there is no turning back either, once that door has closed. A ship that has spent decades building up speed away from the sun cannot simply wheel around and come home, because turning around would cost every bit as much effort as the leaving did, effort it no longer has to spend. The people aboard are committed the very moment they are truly underway. Whatever waits ahead of them and whatever fails behind them, there is no return trip written into the plan and no fuel for one even if there were. The crossing runs in one direction only, outward, always outward, into a dark that does nothing but deepen. So think about what that ship actually is once it clears all of this. A sealed metal world, small and warm and lit from the inside, moving through a dark so complete that the nearest source of real heat is the star it left behind, still the brightest thing in its sky and shrinking every year. Everyone aboard was born knowing that light is home, and everyone aboard will watch it dim to just another star among the field. There is no shore out here. There is no way station, no place to stop and take on more of anything. The ship carries everything it will ever have at the moment it crosses that line, and from then on it is on its own in a way nothing living from Earth has ever been on its own. And that is the part we have never tested, not once. Everything we have ever sent far past the orbit of the moon and left out there for the long haul has been a machine, a robot, a camera and a radio and a slowly cooling power source, feeling nothing, needing nothing, indifferent to how long it takes. No living thing from Earth has ever spent decades, let alone centuries, out in true deep space and returned to tell us what it did to them. We have people who have spent a year at a time in orbit just above the atmosphere, still wrapped in the shelter of Earth's magnetic field, still resupplied every few weeks from the world just below them. That is the far edge of our real experience. Out in the actual dark, with no world underneath and no way back, we are guessing. Careful guessing, informed guessing, but guessing all the same. I think that honesty matters right at the start, because the rest of this depends on it. When someone tells you a great ship could carry the last of humanity onward through the stars, they are describing something no one has ever done at any scale, in a place no living creature from this planet has ever survived for long. It might turn out to be possible, But it is not a settled thing, not a known quantity, and the moment you look hard at the real distances, the confident version of the plan starts to look very strange indeed. Because the ship has cleared the doorstep now. It is out past the last frozen debris of the Sun's family, out through the heliopause, drifting through the Sun's faint outer shell of comets toward the true gap between the stars. And the fastest thing we ever built would still need 70,000 years to reach the closest one. So the question the escape story never asks, the one that quietly decides everything else, is simple and hard. If the fastest object we have ever launched needs 70,000 years just to reach the nearest star, what would a ship carrying living people have to survive to make that same crossing? And is there even anywhere out there worth crossing to at all? That is where we have to start. So let us go and look at the distance itself close up, and then at what is waiting on the far side of it. The distance to the nearest star is not a big number so much as a different kind of number, and the difference is the thing that matters. We are trained by the night sky to think the stars are far but reachable, points of light you could sail toward given enough patience. That instinct is wrong, and it is wrong by an amount that is genuinely hard to hold in the head. So let me try to make it hold. The closest star to the Sun is a small dim red one called Proxima Centauri, part of the Alpha Centauri group. 3 stars bound loosely together off in one direction of the southern sky. 2 of them are bright suns much like ours, circling each other in a slow embrace. The third, Proxima, is a faint red ember that hangs a little apart from the pair, and it happens to be the nearest of all of them to us, which makes it the closest star there is. It sits about 4¼ light years away. That phrase, 4¼ light years, sounds almost walkable, 4 of something and a little more. Do not let it fool you. A light year is the distance light covers in a single year, and light is the fastest thing there is, moving at 300,000 kilometers every second. In 1 second, a beam of light could go around the Earth more than 7 times. And that same impossibly fast beam takes 4¼ years to reach Proxima. Put it in plain kilometers and the number stops pretending to be friendly. Proxima Centauri is about 40 trillion kilometers from here, 40 million. Written out, it is a 4 followed by 13 zeros, and there is no honest way to picture that, so let me anchor it to something instead. The distance from the Earth to the Sun is already so large that light, that same unstoppable light, takes 8 minutes to cross it, which is why the Sun you see has always technically already set 8 minutes ago. Proxima is roughly 268,000 times further away than the Sun. So take the entire gulf between us and the Sun, the one that already dwarfs every distance in human life, and lay it end to end more than 250,000 times over, and only then have you reached the closest star. That is not a longer trip to the moon. That is a different category of thing entirely, a gap so wide that our whole intuition for distance simply stops working inside it. Now put a real ship on that scale. We already saw that our fastest craft, at 17 kilometers a second, would need over 70,000 years to get there. But surely you think we could do better than a probe built in the 1970s, and we can, a little, on paper. Engineers have drawn up designs for ships driven by fusion, or by a rapid string of small nuclear blasts hammering against a heavy plate, and the boldest of those paper ships aim to reach a star like Proxima in something like a single century. 100 years, one way. That is the optimistic end, the dream sketched by the people who have thought hardest about it. And even that dream comes with a catch that swallows it whole. We cannot build any of them. Not a prototype, not a test article, not even the engine on its own. Every one of those fast ships exists only as equations and drawings. We have never flown a fusion rocket. We have never lit the string of blasts. The propulsion that could carry people to another star in a lifetime is entirely theoretical, and has been for over half a century, with no working example anywhere on Earth or off it. There is a clever idea still, and it is worth naming because it shows exactly where the wall is. The boldest current plan does not try to send a heavy crewed ship at all. It proposes firing tiny chips, each the weight of a paperclip, out on gossamer sails pushed by enormous ground-based lasers, whipping them up to a fifth of the speed of light so they could reach the Alpha Centauri stars in only about 20 years. And that might actually work one day for a chip. But notice what has been thrown overboard to reach that speed. The people, the air, the food, the water, the shielding. Everything that makes a ship a place a human could live has been stripped away, until all that is left is a speck of electronics too small to hold a single cell of a living thing. The moment you insist on carrying people, on carrying all that mass, the speed collapses back down and the century becomes tens of thousands of years again. Fast is for specs, heavy is for people. You do not get both. And here is a piece of the problem almost nobody mentions, which makes it worse. Reaching the star is only half the task. If you spend all your fuel and all your effort getting up to speed, you arrive at Proxima traveling so fast that you simply blow straight past it in a matter of hours and carry on into the empty dark on the far side, having seen your destination only as a blur through a port. To actually stop, to slow down and stay, you need to spend just as much energy braking as you spent accelerating, which very nearly doubles an already impossible sum. A crossing is not a single throw. What it takes is a throw and a catch both, and we can barely imagine the throw, let alone the catch. And you cannot slip out of this by simply building a bigger ship with more fuel, which is the answer everyone reaches for first. The deep cruelty of a rocket is that its fuel has weight too, so to carry more fuel you must carry still more fuel to push the fuel you just added, and that extra fuel needs pushing as well, and the whole thing spirals upward against you. Doubling the speed you want at the end does not mean merely doubling the fuel. It can mean many times over the fuel, stacked up in a curve that climbs toward the impossible long before you reach any speed worth having across 4 light years. A rocket of the ordinary kind, built large enough to push a real crewed ship to another star at any useful pace, would have to start out more massive than a planet, almost all of it fuel to burn just to move the rest. That is not a gap in our cleverness. The rocket you already understand fights you harder the faster you ask it to go, and over the gulf between the stars it loses the fight outright. This is exactly why the honest people who study interstellar flight spend so much of their time on the exotic ideas, on light sails and laser beams and antimatter and things we have never made so much as a gram of, because every ordinary method they check runs headlong into the same wall the instant you load it with a crew. The gap is not waiting on one clever breakthrough that is nearly within reach. Instead, it waits on physics we simply do not have, and may never have, to move a mass we cannot make lighter, across a distance that will not shrink, in a time short enough to matter to anyone living. Every real thing we could actually build today lands us straight back at tens of thousands of years, without exception, every single time we run the sums. So we are stranded in an ugly gap between two numbers. The thing we can actually build takes 70,000 years. The thing that takes a century, we cannot build and may never build. And a ship full of the last humans has to live somewhere in that gap, almost certainly far down at the slow end, because slow is the only kind of ship that is real. I want to be careful and fair, because serious people work on this, and the field is not foolish. But the honest state of it is stark. We have no propulsion, none at all, that could carry a crude, life-supporting mass, something heavy enough to hold people and air and food and shielding, to even 1% of the speed of light. Our fastest probe ever, a small craft that whipped close around the sun, touched about 700,000 kilometers an hour, and even that blistering speed is far less than 1% of the speed of light, and it was a brief, unsustainable flick past the sun, not a cruise. At a true 1% of light speed, Proxima would still be more than 4 centuries away. Everything faster than that is a hope with no hardware behind it. Here is a way to feel how strange our situation really is. We have walked on the moon, which sits about a light second and a half away, close enough that a radio call takes only a moment each way. We have flown our robots across the whole solar system, out to worlds that are light hours distant, and even that already strains our patience, commands crawling outward for hours before anything answers. The nearest star is 4 light years off, not light seconds, not light hours, light years. The scale leaps by a factor so enormous that the tools and the patience that carried us across the solar system simply do not reach across the gap between the stars. The distance between the planets and the distance between the stars are not the same problem made larger. They are different problems, and we have only ever solved the small one. And notice what this does to the escape story. In the story, the dying of Earth is a deadline, and the ship is the way to beat it. But a way out that takes 70,000 years is not really beating any deadline. Instead, it is a slow drift into a dark that has no other side within reach. The people who launch are not fleeing to safety. They are launching their descendants, thousands of generations of them, into a crossing not one of them will finish, toward a destination not one of them will ever see. Whether that counts as saving anyone at all is a question I want to come back to right at the end, because it is far harder than it first sounds. But before any of that, before we even ask how you would survive such a crossing, the distance forces a more basic question on us. Suppose you could cross it. Suppose the impossible ship existed and the impossible time could be endured. You arrive at Proxima Centauri after all of it, after the whole unthinkable span. And the question waiting there is whether there is anything worth arriving at. We call the planet around that star habitable. We drop it in the habitable zone and let that one gentle word do an enormous amount of quiet work. So before we spend a single generation on the crossing, we ought to look hard at the thing on the far side and ask whether the nearest new Earth is anything like an Earth at all. Because if it is not, then the crossing, all 70,000 years of it, was aimed at nothing. There is a planet circling Proxima Centauri, and we call it habitable. I want to take that word apart because the nearest habitable world is habitable in name only, and the gap between the name and the reality is the whole point of this section. The planet is called Proxima b, and on paper it reads like a promise. It is a little heavier than Earth, about 1 1/10 times our mass, which means it is almost certainly a solid rocky world and not a ball of gas. It sits inside what astronomers call the habitable zone of its star, the ring of distances where a world could in principle hold liquid water on its surface rather than freezing it solid or boiling it off. And that is exactly where the trouble begins, because of what kind of star Proxima is. Proxima is a red dwarf, a small cool star that gives out only a tiny fraction of the light our sun does. For a planet to be warm enough for liquid water around a star that dim, it has to huddle in extremely close. And Proxima b huddles very close indeed. It circles its star once every 11 days. Its entire year is shorter than a fortnight. It orbits at about 1/20th of the distance from the Earth to the Sun, which tucks it in far closer to Proxima than Mercury sits to our own Sun. And Mercury is a scorched cinder. So already the word habitable is straining under the load. It means only that the planet sits at the right distance for liquid water given how faint the star is. It says nothing whatever about whether water or anything else could actually survive there. And when you look at what that star does to that planet, the promise curdles fast. Proxima is not a calm star. Small red dwarfs like it are wound through with fierce tangled magnetic fields, and they release that pent-up energy in sudden savage bursts called flares. Proxima throws off major flares several times a year, and smaller ones far more often than that. On one occasion, watchers caught it brightening by nearly 70 times over in a matter of minutes, a wall of ultraviolet and X-ray light erupting from a star that is normally too dim to see with the naked eye at all. Now hold that beside how close the planet sits. A flare like that from a star this near washes over Proxima b with a violence our own world never has to face, because our sun is far calmer and we sit much further out, and we hide behind a thick atmosphere and a strong magnetic field besides. Proxima b, so far as we can tell, has almost none of that shelter. Flare after flare, year upon year, for billions of years, that radiation works at the planet's air, stripping it away molecule by molecule and shattering the chemistry any life would need to hold itself together. A world can begin with a fine, thick atmosphere and simply have it scoured off into space by a star that never stops hitting it. And there is a second, quieter problem that runs just as deep. A planet packed in that close to its star almost certainly becomes tidally locked. The star's gravity grips the near side harder than the far side, and over long ages it drags the planet's spin to a standstill, until the same face is turned toward the star forever. One side of Proxima b lives in unending day, the other lives in unending night. On the day side, a dull red star hangs fixed in the sky, never rising, never setting, just sitting there pouring down its weak light and its sudden flares. Walk toward the far side and the star sinks toward a horizon it never crosses, and then you are in permanent dark, standing on ground that has never once felt light from its own sun, cold enough in places that the air itself could freeze out of the sky and fall as frost onto the rock. And on such a world, the day side and the night side are so unequal that the atmosphere, if any survives, can pile up and even freeze out on the cold half, collapsing the whole delicate balance a living world needs. Between the two extremes runs a thin ring of everlasting red twilight where the star sits forever balanced on the edge of the world. And the two halves of such a world are not gently different, they are savagely so. The day side, pinned forever beneath the star, might sit warm enough in places for liquid water if any water and any air still remained, while the night side, which has not seen its sun since the planet first formed, plunges toward a cold deep enough to freeze the atmosphere itself out of the sky, so that on the dark half the very air can fall as snow and lie frozen on the ground. Between them the winds would tear without rest, driven by that permanent gap in heat, roaring out from the baked face toward the frozen one with no season and no night to ease them. And across all of it, again and again, comes the flare, the star flinging out its sudden blast of ultraviolet and hard radiation that would scald a surface and shred the fine chemistry of anything trying to hold on. That is the daily weather of the nearest habitable world, a fixed red sun that never moves, a shrieking wind between a scorched hemisphere and a frozen one, and the regular arrival of radiation strong enough to sterilize the bare rock. Stand on that terminator, on the narrow line between the endless day and the endless night, and look up. The thing in your sky is not a warm yellow sun like the one the ship left behind. What hangs there is a small, sullen red coal, unmoving, that flares without warning into something that would sear an unprotected eye and shred an unprotected cell. This is the nearest habitable world. This is the closest thing to a new Earth that the entire crossing could ever deliver. A tidally locked rock, half of it frozen in the dark, half of it pinned under a flaring red star, its atmosphere very possibly torn away long ago. And Proxima b is no unlucky exception. It is the standard model for the nearest kind of world, and once you see the pattern you find it repeated everywhere you look. A little further out there is a famous small cool red star called TRAPPIST-1, cooler and redder even than Proxima, and around it turns a whole close-packed family of 7 rocky worlds, several of them sitting in its so-called habitable zone. It sounds like a jackpot. 7 Earth-sized worlds in temperate orbits around one nearby star. But they are all huddled in extraordinarily tight, closer to their little sun than Mercury is to ours, their whole years lasting only a handful of days, and they are almost certainly every one of them locked face on to that dim red star, baking on the near side and frozen on the far side, bathed in the same flares. 7 worlds, and the same verdict on all 7. Wherever we point our instruments at the nearest small stars, the picture holds. The habitable planets are not gentle places at all. They are scorched and frozen and flare-blasted, jammed in tight against stars that never settle down. And there are far more worlds like these than there are calm blue planets turning at a safe distance from a steady golden sun. The typical habitable world is a hostile one, and the nearest ones are all typical. I do have to mark the honest edge of what we know, because it cuts both ways and I promise not to cheat it. We do not actually know whether Proxima b still holds any atmosphere at all. We have never seen the planet directly. We know it is there from the tiny wobble its gravity puts on its star, and from that we can estimate its mass and its orbit, but its surface lies beyond our sight for now. It might be bare rock, an airless stone baked and frozen and blasted in turn. It might, just possibly, cling to a thin skin of air, perhaps sheltered on the night side, perhaps fed by processes we do not yet fully understand. That question is genuinely open, and honest scientists argue over it. But notice that even the open version is not hopeful. The best honest case is not a green world with oceans and a breathable sky. The best honest case is a tidally locked planet that might have managed to keep some thin remnant of air against everything its star hurls at it. That, at its most optimistic, is the prize at the end of the nearest crossing. So here is the question I want you to carry forward, because it quietly reframes everything that follows. If the closest world we dared to call habitable turns out to be a flare-scoured, half-frozen rock that may not even have air, then what are the real odds that anything better is sitting within reach of a ship? What are the odds that somewhere in the small handful of stars a slow ship could ever plausibly reach? There is a genuine second Earth, wet and warm and shielded and calm. Hold that question tightly. I am going to answer it directly, with the actual inventory of what is out there, and the answer is not kind. But first we have to face the crossing itself, because we have been talking as though arriving were the hard part. It is nothing of the sort. Suppose you decide to go anyway, knowing the destination is poor. How long does the crossing take, and can anything living survive being sealed inside a single ship for that long? That is where the real killing starts. To cross that distance and survive it, you have to go slow. That sounds backwards, so let me set it out now and pay it off in full later, because it is one of the two jaws of the trap this whole story turns on. For the moment, take it as given. The safe way across the space between the stars is the slow way, and the slow way means a crossing measured not in years but in tens of thousands of them. And that single fact does something quietly monstrous to the escape story. At a speed a real ship could actually hold and survive, the nearest star is not a lifetime away. The nearest star is hundreds of lifetimes away, well over 2,000 human generations, born and grown and gone, one after another, the whole chain of them spent inside a single ship. Think about who those people actually are. The ones who close the doors and launch will die in deep space, having watched the sun shrink to a star among stars. Their children will be born in the dark and will know Earth only as a story told by the old. And then their children, and theirs, on, a chain thousands of generations long, not one of whom launched, not one of whom will arrive, every single one of them living an entire human life sealed inside a machine crossing a gap they never chose. The people who first seal the ship are not sending themselves anywhere. They are committing thousands of unborn generations to be born, to live, and to die aboard, in the service of an arrival not one of them will witness. That is what a generation ship really is, once you take the time honestly. We say the words as though they solve the problem. People adapt, we say. You just need enough generations. But listen to what that actually asks. It asks a human society to hold together, functioning, sane, skilled and willing, across a span longer than all of recorded history, with no new blood, no outside world, no escape and no arrival. Nothing but the same sealed volume and the same finite stores and the same slowly aging machinery. For hundreds of centuries, we have never done anything remotely like it. Every closed community we have ever attempted, every sealed experiment, every isolated outpost, has been tiny and has lasted at most a handful of years before something in it frayed and split. The people inside such places turn on each other, form factions, lose the thread of why they are there. We are asking that not to happen for 10,000 years. That is a very large thing to assume, and the escape story assumes it without a blink. And there is a harder, colder version of the same problem, one you cannot fix with good behavior, because it is written in the biology. A closed population of people needs to be large enough to stay healthy across the generations. Too few of them, and the same handful of family lines marry back into one another again and again. And the hidden faults every one of us carries start to double up and surface, until the children are sicker than their parents and the line begins to fail. To avoid that slow genetic collapse across thousands of years, you need not a few dozen colonists, but a few thousand of them at the very least. Thousands of people and all their food and air and water and shielding, which makes the ship far heavier, which makes it far slower, which makes the crossing far longer, which feeds straight back into every other problem we have met. And remember, the rain of radiation is quietly breaking the very cells that make the next generation the entire time. So the biology is fighting uphill against the dark even to hold its ground. Then there is the quieter loss, the one that has nothing to do with bodies. The people who launch will understand their ship. They built it, or their parents did. They know why they are out here and what every system does and how to mend it. But the 50th generation inherits none of that firsthand. They are born into a set of machines they did not design, sent on a mission they never chose, by ancestors 1,000 years dead. Every skill the ship depends on, every repair, every scrap of medicine and engineering and farming, has to be taught perfectly, generation after generation, for hundreds of generations without a break, because the moment a skill is dropped, it cannot be relearned. There is no outside world to look it up in, no other town that still remembers, no library that was not packed aboard at the start. A civilization on a planet can forget things and recover them, because the knowledge survives somewhere else. A ship that forgets how to fix its own air simply dies of it, in the dark, with no one left who knows what went wrong. And there is a will problem hiding beneath the skill problem, which may be worse. The founding crew chose this. They believed in it, they signed their descendants up for it, they carried the purpose aboard like a flame. But purpose is not passed down through the blood. Somewhere down the long chain of generations, people are born who never agreed to any of it, who look around at the sealed dimming vessel that is the only world they have ever known and ask, reasonably, why they should spend their one life maintaining a crossing toward a place none of them will live to see. A crew that stops believing in the mission, stops tending it with the fierce care a doomed system needs, and a system tended with anything less than fierce care fails all the faster. The escape depends not just on thousands of generations staying skilled, but on thousands of generations staying willing, holding to a purpose their ancestors chose for them, in the dark, for reasons that grow more abstract with every century that the sun falls further behind. But set the people aside for a moment, because I want to show you something out there in the dark they are crossing. The escape story imagines interstellar space as pure emptiness, a clean black nothing between the warm star behind and the warm star ahead. It is emptier than anything in human experience, yes, but it is not empty of worlds. As the ship grinds across the light years, it passes things out there in the dark, drifting between the stars with no sun of their own, are planets, whole worlds, some as small as Mars, some as large as Earth, some larger, thrown out of the systems where they were born and set loose to wander alone forever. We call them rogue planets, and they are not rare curiosities. There are billions of them. By some estimates, there may be more of these starless wanderers in our galaxy than there are stars, which would make the lonely worlds the single most common kind of world there is. We have even begun to catch a few of them directly, spotting the faint gravitational tug of an Earth-sized rogue against the light of a distant star behind it, confirming that yes, these orphan worlds are truly out there, adrift and countless. Consider plainly what one of them is, because plain statement is all it needs. A rogue planet has no sun in its sky, none at all. Not a dim one, not a distant one, nothing but the scattered pinpricks of far-off stars, far too weak to warm anything. Its surface sits in a cold near the deepest cold there is, hundreds of degrees below freezing, because there is no star pouring energy onto it, and there never will be again. Whatever gases it once carried are frozen out onto the ground as frost and ice, or were lost to space long ago. The only warmth such a world holds at all is the faint leftover heat buried deep in its own core from the day it formed, slowly leaking away into a dark that will never give any of it back. It keeps no year, since it circles nothing at all. It has no seasons, no dawn, no dusk, just an unbroken frozen dark that has already lasted longer than our species has had a name and will last, for every purpose that matters, without end. There is a strange twist to a few of them, worth admitting for honesty's sake. A rogue world large enough, wrapped in enough ice, might just keep a hidden ocean of liquid water deep underground, warmed only by its own slow inner heat, sealed under kilometers of frozen crust in total darkness. But an ocean in the pitch black, cut off from any sun, is no home for us. It is at most a place where the very simplest life might cling on unseen. It is not a shore anyone could sail to. And this is the first place I want you to feel something the ship's crew would feel, if they ever let themselves think about it. The ship is a sealed thing, dark on the outside, carrying its own warmth in a thin shell against a cold that wants every scrap of it, drifting through the dark with no star to belong to. And out there, sliding silently past in the distance, is a rogue planet. A sealed, frozen world, dark, carrying the last of its own warmth deep in its core, drifting through the dark with no star to belong to. Already, out ahead, the first of the drifters slides by. And if you look at the ship and then at the rogue world, and you are honest with yourself, they are the same kind of object. The ship is only warmer for now, and it has people in it for now. It is quietly on its way to becoming one of them. Hold on to that. It is going to come back, and each time it comes back, it is going to weigh more. For now, let the crew pass the drifter and press on, because I have been speaking of generations and centuries, and the long grind of the crossing as though the ship itself were a fixed thing, a reliable floor beneath their feet, and that is the next assumption I have to take away from you. The people might endure, perhaps, but the machine has to endure too, and the machine is the part we can actually test, and what the tests say is not encouraging in the slightest. So forget the human beings for a moment, hard as that is to do. Can the ship itself, the sealed system of air and water and food and power, run for 10,000 years without a single failure it cannot fix? Can any closed machine ever built by anyone do such a thing? Let us go and look at the one time we tried to build a small sealed world and keep people alive inside it. Because the honest answer to whether the machine lasts is where this turns from grim into something worse. No sealed system for keeping people alive has ever stayed in balance for even a single year. That is not a guess or a gloomy mood. That is the record, the actual best we have ever managed, and a starship would have to beat it by a factor of 10,000. So let me tell you what happened the one time we truly tried, because it is the hardest fact in this whole story, and almost nobody who tells the escape story has bothered to look at it. We built once a genuinely sealed little world. A great glass and steel structure closed off from the outside, holding its own air and water, its own patch of growing plants, its own small crew, cut off from the planet around it, the way a starship would be cut off from everything. The idea was to close the loop. The air the people breathed out would feed the plants would hand back the oxygen, the water would cycle round and round, the food would grow inside, and the whole thing would run as a small self-contained living machine, exactly as a starship or a colony on another world would have to. And it did not work. It began to fail almost at once, and it failed in ways nobody had predicted, and that unpredictability is the part that should frighten you most. The oxygen began to disappear. Slowly at first, then unmistakably, the air inside grew thin. Over the months, the oxygen fell from about a fifth of the air, which is what you and I breathe without thinking, down toward a seventh, a level where people move slowly and think slowly and gasp for breath climbing the smallest slope. And the strange part, the part that took them a long while to work out, was where the oxygen was actually going. It was not one dramatic leak, it was the soil. The rich living soil they had brought in to grow their crops was thick with microbes, and those microbes breathed the oxygen far faster than anyone had reckoned. Worse still, the bare concrete of the structure itself was quietly drinking oxygen straight out of the air through slow chemistry nobody had planned for, locking it away in the walls where no one could ever get it back. A sealed world, it turned out, has 1,000 hidden mouths, and some of those mouths are the very walls that hold it. That was only the beginning of the trouble. The crops grew poorly, so the people were hungry, genuinely hungry, and over the long stretch inside they lost weight, a serious fraction of their body mass, simply melting off them from want of food. The carefully chosen balance of living things they had sealed in came apart in their hands. Species they had picked with care sickened and died, and species they had never invited flourished and took over. Insects they had not planned for bred without any check, and swarmed through the growing areas, devouring what the people needed to live. The delicate designed web of life collapsed down into a crude and brutal one, ruled by whatever could stand the chaos, and the people inside were left tending a system that was actively turning against them, in thinning air, on short rations, sealed in with no way out, and the people themselves frayed. Cut off, hungry, short of breath, They split into factions and turned cold toward one another, which is its own kind of warning about what 10,000 years of confinement might do to a crew. Now hold all of that against the length of a starship crossing. That sealed world was meant to run for 2 years, and it barely staggered through them, leaking oxygen and shedding species and starving its crew and splitting its people, and it was sitting on the surface of a living planet the entire time, with engineers on the outside able to watch, to advise, to send things in, and in the end to open the doors and let everyone out into the open air. An earlier and more modest attempt managed to keep people going in a closed loop for about half a year, recycling most of its water with the help of tanks of green algae. And that stands as one of the very longest anyone has ever truly sealed a human life support system and held it shut, half a year. The best we have ever done is measured in months. A starship to the nearest star on the slow, safe road has to hold that same trick for tens of thousands of years, with no engineers outside, no doors to open, no planet underneath, and no way to bring in a single new atom of anything. And this is where the space station always comes up, because someone always says, but we keep people alive in space right now, for months at a time, up there in orbit. We do, and it is worth being clear-eyed about why that works, because the reason it works is precisely the reason a starship cannot. The station keeps people alive by being fed constantly from below. A steady stream of ships climbs up to it carrying fresh water, fresh air, fresh food, new parts, and hauls the waste and the failures back down. The station is not a closed world in any real sense. What it really is an outpost at the end of a very long supply line, tethered to a living planet just beneath it that restocks it every few weeks. Cut that line, stop the climbing ships, and the station turns into a death sentence in short order. A starship, from the moment it crosses the heliopause, has no line at all. There is no world beneath it. There is nothing to draw on but what it carries, and what it carries at the moment the doors close is every resource it will ever have. There is a purely mechanical version of this same doom, quite apart from the air and the food. Every pump, every seal, every valve, every bearing, every joint on that ship will fail, not once but many times over 10,000 years, because nothing built has ever run that long. On Earth you replace the broken part. On the station you fly a new one up. On the ship you have only the spares you packed at launch, a finite pile of them, and no mine, no factory, no fresh ore anywhere in the dark to make more. Every repair spends the stock, and the stock only ever shrinks, and there is no resupply behind it, ever. Sooner or later something critical breaks after the last spare for it is gone, and there is simply no version of the story where that does not eventually happen. And the same rain of radiation that works on the crew works on the ship itself, all the while. Over thousands of years, the constant sleet of particles from the dark slowly embrittles metals, clouds, and cracks any glass, and scrambles the delicate electronics that run everything aboard, flipping and corrupting the very systems the crew depend on to stay alive. The ship ages faster than anything on a planet would, because a planet's magnetic field and thick air hold that damage off, and the ship has neither. So the machinery is not merely wearing out from use. The dark itself is tearing at it from the outside every second, grinding it down as the ship crosses, while the pile of spare parts to fix it only ever shrinks and can never be added to. The ship is a thing trying to hold itself together against an environment that is patiently taking it apart at every level at once, from the crew's cells to the hull's steel to the memory in its computers. Set the ship against a world that genuinely does last. Out around Jupiter there is a moon called Callisto, a great dark cratered ball of ice and rock, and its face is one of the oldest surfaces in the whole solar system, scarred with craters piled on craters, almost none of them ever erased, running back close to 4 billion years. Callisto has endured essentially unchanged, for a span beside which the whole of human history is a single blink, and it has done it by the simplest method there is. It does nothing. It holds no delicate balance, runs no loops, keeps nothing alive, needs no spare parts. It is a cold, dead, stable stone, and cold, dead, stable stones can sit in space for billions of years because there is nothing left in them to break. That is the only kind of thing that truly lasts out there in the long dark. The ship is the exact opposite of Callisto. The ship lasts only so long as it keeps everything moving, the air cycling, the water turning, the plants growing, the reactor running, every failure caught and mended, every loop closed and held closed, every single day, for longer than our species has so far existed. The moment any one loop breaks for good, with no world to draw on and no way to reach in from outside, the ship stops being Callisto and becomes the sealed structure with the vanishing oxygen. It begins quietly to die. I want to be fair about the edge of this, because I have been hard on it. We have never truly closed the loop, which means we do not actually know the real ceiling. A far better system than anything we have yet built might one day be made, one that holds far longer, and I am not going to pretend we have proven that impossible. But be clear about what the fairness comes to. The most we can honestly say is that we have never done it, that every attempt so far has come apart in months or a couple of years, and that we have exactly zero evidence any sealed living system can hold for the timescales a real crossing demands. Hope is not evidence, and even if the recycling were somehow made perfect, there is a deeper reason a sealed ship cannot run without end, a reason that does not care in the slightest how good your engineering is, a reason written into the laws of physics themselves. So let me show you the wall standing behind all the other walls. Even a perfect machine loses, and it loses because of a law that nothing in the universe has ever broken. This is the wall behind all the other walls, and unlike leaks and hungry microbes and worn-out bearings, it cannot be engineered away because it is not an engineering problem at all. What it really is a property of everything that exists. The law is the second law of thermodynamics, and it sounds like a dry piece of jargon until you watch it working, so let me say it in plain words. In any closed system, disorder always increases. Usable energy always turns, bit by bit, into unusable energy, and never the other way round. Every time you do anything whatsoever, every time you burn fuel, run a motor, warm the air, pump the water, split a molecule apart and put it back together, some of the energy you started with escapes as waste heat, low and useless, and you can never gather it back up. Nothing runs at perfect efficiency. Nothing recycles completely. There is always a tax, and the tax is always paid in heat that leaks away and in order that quietly comes undone. You can slow this down. You can be enormously clever about it. You cannot stop it, and you cannot reverse it, because in all of history, nobody and nothing ever has. Now put that law inside a starship far from any star. The ship is a closed system running 1,000 processes just to stay alive, and every one of those processes sheds a little waste heat and loses a little order that has to be paid back somehow. On a planet you barely notice this because a planet is not closed. A world has a great furnace hanging in its sky, pouring fresh energy down onto it every single day, driving the winds and the water and the growth of every living thing, endlessly topping up the account. The sun does that work for us for free, and it will keep doing it for billions of years yet. But a ship in the dark between the stars has no such furnace overhead. It left its sun behind. Out there, nothing rains down, nothing refills the account when the tax comes due. There is only what the ship carries and what the ship can throw away into the cold, which is precisely the wrong direction. The one thing the deep dark will freely hand a starship is somewhere to lose its heat. It will not give the ship a single scrap of energy back. So the ship is running on a finite store. However large the tank of fuel, however powerful the reactor, it holds a fixed amount of usable energy, and the second law guarantees that store only ever shrinks. The reactor winds down, the fuel depletes, the parts wear, and every repair spends more order to buy a little back, and the repair is never free either, and the tools that make the repair wear out too. There is no arrangement of machinery, however brilliant, that lets a sealed ship draw endlessly on a finite store, while the second law quietly takes its cut at every single step. And there is a trap folded inside the obvious answer of simply carrying more energy. Every scrap of power the ship uses ends up, in the end, as waste heat that has to be got rid of, because if it builds up, the ship slowly cooks itself from the inside. The only way to shed that heat in the dark is to radiate it away into space through great thin panels, and the more power you run, the more heat you make, and the larger and more fragile those radiating panels have to be, hung out into the very dust and radiation that is trying to erode everything. So carrying a bigger store of energy does not simply buy more time. It buys more heat to dump, more delicate surface to dump it from, and more of the ship exposed to the dark that wants to wear it down. The books do not balance in the ship's favor no matter how you arrange them, because the second law has quietly written itself into every column. Forever, in the plain and literal sense, is off the table. And it is not off the table because the engineers fell short. The gap is deeper than any question of skill. A closed system with a finite supply of usable energy, losing a little at every turn and gaining nothing back, must run down in the end. That is not a flaw in the ship. That is the rule the ship is made of. Remember the small craft I mentioned at the very start, our fastest ambassador, going quiet out past the heliopause as its plutonium decays and its instruments shut down one by one. That is this same law, playing out right now on a real thing we built and love. It is not failing because we built it badly. We built it beautifully. It is winding down because everything winds down, because a warm-made thing adrift in the cold with a finite store has only one direction it can go. The great ship carrying the last of us would be doing exactly the same thing, only slower, and with people inside to feel the lights go dim. And if you want to see this same law written across the whole sky, look at a dead star. Out there, scattered through the galaxy, are white dwarfs, the burnt-out cores of stars that have already spent everything they had. A white dwarf is what our own sun will one day become, an object about the size of the Earth but holding close to the mass of a whole star, packed so ferociously tight that a single spoonful of its stuff would weigh as much as a small mountain. It no longer burns. It makes no new energy of any kind. All it does now is sit in the dark and slowly leak away the leftover heat of the star it used to be, cooling, dimming, fading, century after century, giving its warmth to the cold around it, and getting nothing whatever in return. Given long enough, it will cool into a cold black cinder, a dead ember drifting dark, a thing called a black dwarf. And here is the fact that makes it land in the gut. The time a white dwarf takes to finish cooling into that final black state is longer than the entire universe has so far existed. The universe is simply not old enough yet for even a single one of them to have gone completely cold. Not one black dwarf exists anywhere, because there has not been enough time. That is the pace of this law at the scale of a star. Slow beyond all imagining, but always in the one direction, always downhill, always toward cold and dark and done. The ship is a tiny version of exactly that. A warm lit thing adrift in a great cold, radiating its heat outward into the dark, running down its store, unable to refill it, sliding by inches toward the same end that every warm sealed thing in this universe slides toward. It is a white dwarf you could walk around inside. The scale is wildly different. The direction is identical, and the universe itself, given long enough, does the same thing whole, every star burning out, every ember cooling, the whole of it drifting at last toward an even, lifeless cold where nothing can happen anymore because there is no longer any difference in heat left to drive it. That final state has a name, the heat death, and it is where the second law is taking everything, the ship and the star and the galaxy alike, at their different speeds. Now I want to be honest about what this does and does not prove because it is easy to overreach with it. The second law sets an outer bound, not a near-term one. Entropy does not kill the ship next year or next century. It ranks as the slowest of all the killers we are going to meet, the one that keeps to the timetable of dying stars. What it does is close off the word forever, completely and permanently, even in principle, even for a flawless machine. It says that no matter how good the ship is, running without end was never a thing physics would allow. But it also means, and this part matters, that the thing which actually ends the ship will not be this grand cosmic law at all. What ends the ship will be something far cruder and far sooner, a broken loop, a lost gas, a failure no one aboard can fix, arriving thousands of years before entropy would have finished the job on its own. The universe sets the ceiling, the plumbing sets the deadline. So here is where a sharp listener pushes back, and it is exactly the right push to make. Fine, you say. If the slow ship winds down over the long haul, and the sealed loops fail over the centuries, then do not go slow. Go fast. Race across the gap before any of it can catch up with you. Beat the clock with sheer speed. Surely, if the trouble with the slow road is time, then more speed is the cure, and interstellar space, being so gloriously empty, should let you go just as fast as you dare. It is the natural move. It feels like the way out, and it walks the ship straight into the second jaw of the trap, which is worse than the first. Because the emptiness you were counting on is not as empty as it looks, and at high speed it stops being empty at all. Let me show you exactly what happens when you try to go fast. Interstellar space is not empty. That is the sentence that closes the trap. So let me prove it to you carefully, because everything about going fast depends on it. The space between the stars looks like perfect nothing, and by the standards of anything on Earth it very nearly is. But very nearly is not the same as nothing, and at high speed the difference between very nearly nothing and true nothing turns out to be the difference between arriving and being torn apart. Here is what is actually out there. The space between the stars holds on average about 1 atom in every cubic centimetre. 1 atom in a volume the size of a sugar cube. That is a thinner gas than anything we can make in the best vacuum chambers on Earth. An emptiness better by far than the void inside a light bulb. It sounds like nothing worth counting at all, and we happen, as it turns out, to sit in an especially empty patch of it, a great cavity in the gas called the local bubble, blown clear long ago by exploding stars, stretching about 300 light-years around us and running perhaps 100 times thinner than the galaxy's average. So our own corner is emptier still. And none of that saves you because of what speed does to even the thinnest gas. The trick your intuition misses is this. When you are the one moving fast, every one of those still, harmless, thinly scattered atoms comes at you. It does not matter that they are far apart from one another. What matters is how many your ship sweeps up as it tears through them, and how hard each one hits when it arrives. Sit still, and interstellar space is almost perfectly harmless. Fly through it at a serious fraction of the speed of light, and every atom in your path becomes a bullet, and the thin gas becomes a gale of radiation blowing straight into the nose of the ship. Take the individual dust grains first, because they are the vivid killer. Scattered through that thin gas are tiny grains of solid matter, most of them far smaller than a speck you could see with the naked eye. A large one might be about the width of a single human hair, utterly harmless, sitting still. Now hit it at 1/3 of the speed of light, which is the sort of speed you would need to reach another star inside a human lifetime. At that speed, a single grain the width of a hair carries the energy of a mass of about 100 tons moving at motorway speed. Let that land properly. One dust mote, invisible, drifting quietly in the dark, delivers to the front of your ship the full punch of a 100-ton lorry at speed on a road. One of them. And your ship, crossing light years, will meet not one but a steady, endless stream of them, each strike blasting a crater into the leading face, flashing the point of impact into a burst of vaporized hull and glowing plasma, eating the front of the ship away grain by grain over the whole length of the crossing. To go fast enough to arrive in a lifetime is to drive the nose of your ship into an endless sandblast where every single grain of sand hits like a runaway lorry. And the gas itself, the thin scatter of lone atoms, does something quieter and just as deadly. At these speeds, those atoms are not gentle either. Each one slams into the front of the ship hard enough to bury itself in the material or to knock loose a spray of particles, and taken together, hour after hour after hour, they heat the leading face and carve microscopic tracks of ruin down into it. The heaviest of them, the atoms of iron and oxygen mixed through the gas, punch the deepest, drilling narrow channels of damage through the surface layer. And more than that, at a large enough fraction of light speed, the oncoming gas stops behaving like gas at all and starts behaving like radiation. The atoms arrive with so much energy that meeting the hull is like standing in the beam of a particle accelerator. The faster you go to beat the clock, the more the front of your ship glows under a wind of raw radiation, and the deeper the damage cuts, and the more of that radiation drives on through the shell toward whatever is sheltering behind it. After centuries of this, the front of such a ship would not look built anymore. The leading face, whatever it began as, would be cratered and cratered over again, pitted and scorched and eaten slowly back, glowing faintly from the endless stream of impacts and the wind of radiation pouring into it. The nose of the ship would be its open wound, taking the full weight of the crossing so that the crew tucked behind it might live a little longer, wearing away layer by layer with nothing to mend it and no way to replace what the dark grinds off. A ship crossing at speed does not sail cleanly through the dark. It burrows through it face first, and the dark files it down the whole way. So look hard at what has just happened to the argument. We came to speed as the answer. The slow road failed us because of time, because the sealed loops give out and the store runs down over the tens of thousands of years the crossing takes. So we said, then go fast, beat the time. And going fast turns the near-empty dark into a solid wall. The dial that controls all of this has two ends, and both of them are fatal, and there is nothing safe in the middle of it. Turn the dial towards slow, and you survive the medium. The gas and dust barely touch you. But the crossing takes so long that the ship wears out and the loops fail and the people are gone 100 times over before anywhere at all comes into reach. Turn the dial toward fast and you beat the time, but the medium tears the ship apart, sandblasting the nose and cooking the leading face in radiation long before you arrive. Slow enough to survive the dust is far too slow to survive the years. Fast enough to survive the years is far too fast to survive the dust. That is the spike of this whole story, the place where the floor drops out from under it. Because up to this point you could still quietly tell yourself there was a way through. The loops might fail, but perhaps you build them better. Entropy might loom, but entropy is far off. There was always the sense that with enough cleverness a path remained open somewhere, and here the path closes. There is no speed that gets a ship full of living people across the gap between the stars and out the far side alive. Not slow, not fast, not the careful middle. Every speed kills you, just in a different way and on a different timetable. The emptiness we were counting on to save us is the very thing that bolts the last door. I want to be fair because there is an obvious answer and it deserves a proper hearing. Shield the ship. Put a great thick barrier across the front, a wall of matter to soak up the dust and the gas and the radiation, and hide the people safely behind it. And yes, a big enough shield helps. It genuinely does. Water is good at it, or packed rock, or thick metal. But follow the idea all the way through because the shield does not escape the trap. It only moves it. A shield is mass. A thick wall of matter across the front of the ship is enormous weight. And every extra ton you bolt on is another ton you have to accelerate up to speed, and then slow down again at the far end using fuel you do not have and an engine you cannot build. The more heavily you shield against the fast road's dangers, the heavier the ship becomes, and the heavier it becomes, the harder it is to go fast at all, which shoves you straight back down toward the slow road and its own long, patient killing. Shielding does not break the trap. It trades one jaw of it for the other. There is no proposed design anywhere, none, that slips cleanly between the two. There is even a problem simply in aiming the thing. Over the tens of thousands of years the crossing takes, nothing stands still. The target star is itself moving through the galaxy, and so is the sun, and so is everything else, all of it drifting on its own long path. So you cannot aim the ship at where the star is. You have to aim it at where the star will be after all those millennia have passed. A spot that is empty now and will only fill much later. And you have to get that aim almost perfectly right at the very start, because out here the smallest error in angle, spread across 4 light years, grows into a miss measured in the width of whole solar systems. Steer wrong by a hair at launch and you sail clean past your destination by a distance greater than the destination's entire reach, with no fuel left to correct and no way to turn. You are firing an arrow over 10,000 years at a target that is also moving, and you only get to loose it once. And it gets a shade worse even than that, because our empty local bubble does not last the whole way. Push far enough in any direction, and the ship eventually crosses out of our thin, quiet cavity and into the ordinary gas of the galaxy, which is denser, sometimes far denser, thick clouds of it in places. Everything I have just described, the sandblast and the radiation gale, gets stronger the moment the ship leaves the shelter of our unusually empty neighborhood. The one thing making the fast road even slightly survivable is that we start out in a bubble, and the bubble runs out before the crossing does. So the honest picture, once you take both roads seriously, is not a hard crossing that clever people might one day manage. Instead, it is a crossing with no safe speed anywhere on the dial, walled in by time on the one side and by the medium on the other, and aimed, remember, at a destination we already saw is very likely a frozen or an airless rock. I have been almost entirely bleak about it, and I have been bleak on purpose, because the science has genuinely earned every bit of it. There is one honest exception to all of this. One way this whole grim picture might still leave a door open, and I am going to get to it, but not yet. First, I have to show you the killer that never lets up, no matter how fast or slow you go. Even if you found a safe speed, and you cannot, there is a killer that would still be working on the crew every second of the crossing, slow and patient and impossible to switch off. It is the rain of cosmic rays, and it is the reason that even a ship drifting at a careful middle pace, touched only lightly by the dust and the gas, would still be quietly poisoning the people inside it the entire way across. Out in deep space, far from the shelter of any planet, you are being struck constantly by particles arriving from every direction at once. These are the galactic cosmic rays, and they are not the mild sort of radiation you might be picturing. What they really are the bare nuclei of atoms, stripped of everything, flung across the whole galaxy at very nearly the speed of light. Most are the light ones, lone protons, the cores of hydrogen, but mixed in among them are the heavy ones, the nuclei of iron and other massive atoms, moving at those same brutal speeds, and a single heavy nucleus like that carries so much energy that when it passes through living tissue it tears a track of wreckage clean through every cell that lies in its path. This rain never stops, and it comes from all sides at once, and out in true deep space there is nothing whatever to hide behind. On Earth we never feel it, and it is worth understanding why, because the why is exactly what the ship does not have. Our planet wraps us in two shields, one behind the other. First there is the magnetic field, a great invisible cocoon thrown up by the churning molten iron in the Earth's core, reaching far out into space and turning aside most of the charged particles long before they ever get near the ground. Then, underneath that, there is the whole thick weight of the atmosphere, an ocean of air kilometers deep above every head, soaking up almost all of whatever the magnetic field lets slip through. Between the two of them, by the time anything reaches the surface, the rain has been softened to a faint, harmless drizzle we can stand under happily for a lifetime. A starship has neither of these things. It has no molten core throwing up a magnetic cocoon, and it has no ocean of air overhead. It has only the thickness of its own walls, and against particles moving this fast, ordinary walls are very nearly nothing. Put numbers on it, carefully, because the numbers are the whole argument. Out in open space, beyond any planet's shelter, the dose soaking into the vulnerable tissues of the body, the marrow deep inside the bones where fresh blood is made, runs at roughly half a sievert every year. If that unit means nothing to you, hold it this way. That yearly deep space dose sits far above the limit we allow any worker on Earth to take across a whole career, and it arrives not once but every single year, without a pause for as long as the ship is out in the dark. And you cannot simply wall it away. Put 30 centimeters of solid aluminium between the crew and the void, a serious slab of metal as thick as your forearm is long, and it cuts the dose only by something like a quarter to a third, not by half, nowhere close to all of it. Most of the rain still comes straight through, and here is the truly perverse part. When the fastest of these particles smash into thick shielding, they shatter the atoms of the shield itself and spray out a whole shower of brand new particles on the inner side, so that past a certain thickness, piling on more shielding hands the crew a fresh problem instead of solving the old one. The rain does not merely pass through the wall, it can turn the wall into a second source of the very thing you are trying to block. There are cleverer shields than slabs of metal. Water works better for its weight, and so does anything rich in hydrogen, packed thick around the places where the crew sleep. But now you are back inside the trap from the last section, because water and hydrogen and rock are all mass, tones upon tones of it. And mass is the one thing the ship cannot carry and still hope to move. Shield the crew properly against the rain, and you have built something far too heavy to go anywhere. Keep it light enough to fly, and the rain gets in. The same jaw closes from a different angle. Now stretch the whole thing across the true length of a crossing. A slow ship is out in that rain not for a year, not for 10, but for thousands upon thousands of years, generation after generation soaking in it without relief. The total dose, added up across such a span, is beyond anything a body was ever built to survive. The near-term price is cancer, in the crew and in the crops and in every living thing aboard alike. The longer price is worse and stranger than cancer. This kind of radiation, the heavy nuclei above all, damages the fine machinery of the brain and the nervous system, dulling thought and memory and mood in ways we are only beginning to measure, and it damages the heart and the blood vessels, and over the generations it reaches into the very cells that make the next generation, and quietly breaks the ability to have healthy children at all. A ship could set out with a sound, sharp, capable crew, and over the long centuries in that rain, watch its people grow ill, watch minds fog and bodies fail, watch fertility itself falter, until the crew that was meant to carry humanity onward can no longer even carry itself forward through time. The crossing does not need to breach the hull to kill everyone aboard. It only needs to keep raining, and it does, forever from every side. There is a particular cruelty in what the heavy particles do to the brain. When one of those iron nuclei drills through the soft tissue of the mind, it does not simply raise a distant risk of illness decades later. The studies we have suggest it dulls thinking and memory and steadies moods less well, that a brain under this rain works a little worse and feels a little worse, and that the damage builds. Now set that beside everything else the crew is enduring, the confinement, the thin margins, the knowledge that no one is coming and nowhere is waiting. A crew whose minds are being slowly clouded by radiation, sealed for life in a failing machine, with morale to hold and skills to pass on flawlessly for 100 generations, is being asked to do the hardest thing humans have ever attempted, while the dark quietly makes them less able to do it with every passing year. The rain does not only threaten to give them cancer, it threatens the very clarity and steadiness the whole desperate project leans on. And I want you to know where this rain is actually made, because it keeps the camera exactly where it belongs, out in the dark and nowhere near any laboratory. Those iron nuclei tearing through the crew were not born anywhere close by. They were forged and flung out by the most violent deaths in the entire galaxy, the explosions of dying stars. When a massive star reaches the end of its life and blows itself apart in a supernova, the shell of shattered matter it throws off comes tearing outward through space at a speed almost beyond reckoning. And the shock front of that blast acts as a colossal natural accelerator, seizing atomic nuclei and whipping them up to nearly light speed before hurling them out across the galaxy in every direction. Look at the ragged, glowing wreck of the Crab Nebula, the still expanding remains of a star that was seen to explode long ago. And you are looking at one of the very engines that manufactures the particles that will one day sleet through the ship and the people in it. Stand off at a distance from a wreck like that, and it is almost beautiful, a great glowing tangle of shredded gas many times wider than our whole solar system, still tearing outward at millions of kilometers an hour from a blast that happened ages ago. At the heart of some of them spins the crushed corpse of the dead star itself, a ball no wider than a city but so dense that a single sugar cube of its matter would weigh as much as a mountain range, whipping round many times a second and lashing the wreckage around it with radiation. These are the forges. This is where the iron nuclei that will one day pass through a crew are made and flung out. And they are not rare freak events tucked away in some far corner of the sky. The galaxy has been lighting up with these deaths for billions of years, seeding the whole of the space between the stars with fast, heavy particles, so that there is nowhere at all a ship could steer to climb out from under the rain. The dark between the stars is not clean, and it is not empty. What fills it is the ash and the shrapnel of every star that has ever died, still in flight, and the ship has to fly straight through it. The crew would never see the star that killed them. It might have blown itself apart ages before any of them were born. On the far side of the galaxy, its wreck still coasting outward, its particles still crossing the light years, arriving one by patient one through the hull to do their slow work on the bodies inside. The dark is not indifferent to the ship by some accident. The whole of it is threaded through and through with the leftovers of stellar violence, and the ship has no choice but to cross straight through the middle of them. I have to mark the honest edge here too, because it is real and I will not skip it. We do not fully understand what a low but relentless dose does to a body across centuries, because no living thing has ever been exposed to it in that way. Our numbers come from shorter, sharper exposures, and stretching them across 1,000 years of steady drizzle is an educated extrapolation and not a measured fact. The real answer may turn out somewhat kinder than the models fear. It may just as easily turn out a good deal worse. But notice once again the shape of the uncertainty. The best realistic case is not that the rain turns out to be harmless. The best realistic case is only that it is very bad rather than certainly and swiftly fatal. That is the shape of nearly every unknown in this whole story. The uncertainty never once points toward rescue. It only ever points toward the question of how bad exactly the bad thing is going to be. So the slow road kills you with time and with rain, and the fast road kills you with the medium, and the careful middle road kills you with the rain as well, only a little more slowly, which leaves one question still standing, the one that decides whether any of this crossing was ever worth attempting in the first place. Say you could somehow survive all of it. Say the ship held and the crew endured, and the rain was somehow born. What exactly is waiting out there to reach? We looked hard at the single nearest option and found a flare-scoured rock. Now let us count the rest of them. Let us take an honest census of every kind of world a ship could ever plausibly reach, and ask how many of them are anywhere worth crossing an ocean of dark and time and radiation to arrive at. Count what is actually out there, honestly, and the census reads like a graveyard. The galaxy is full of worlds. That part of the escape story is true, and it is the part that keeps the hope alive, because surely, with so many planets scattered everywhere, one of them must be a new home waiting. So let us go through them, the real inventory of what a ship could reach, and see how many are anywhere you would actually want to arrive. Start with the lonely ones, the rogue planets we already met drifting between the stars. There are billions of them, perhaps more of them than there are stars in the whole galaxy, which would make them the single most common kind of world in existence. And every one of them is dead in the same way. No sun, no warmth arriving from outside, a surface hundreds of degrees below freezing, whatever air they once had frozen solid onto the ground or lost to space long ago. A ship crossing the dark will pass far more of these than it passes stars. They are the most abundant real estate anywhere, and not a single one of them is a place a living thing could stand and breathe. The commonest world in the galaxy is a frozen sunless stone, and there are more of those than there are candles to light them. So the wanderers are out. What about the worlds that at least still have a star to circle? Here is where the escape story pins its real hope on planets orbiting other suns. And here too the census turns harsh because of what most stars actually are. The great majority of stars in the galaxy, roughly 3 out of every 4, are red dwarfs. Small, dim, cool stars just like Proxima. That is not the exception. That is the ordinary star, the standard issue sun, and it means that most of the planets out there sitting in a so-called habitable zone are circling a red dwarf, tucked in tight the way Proxima b is tucked in tight, tidally locked with one face baked and one face frozen, and blasted by flares from a star that never settles. The commonest kind of habitable world is not a gentle second Earth. What it really is another Proxima b, and we already stood on its terminator and saw what that amounts to. The single most abundant sort of potentially watery planet is a flare-scoured, tide-locked rock, and there are many times more of those than there are calm blue worlds turning under steady golden suns. And it is not as though the nearby ones are any different, because we can name the neighbours and check. Set aside the Alpha Centauri stars, and the very next nearest star to the Sun is Barnard's star, and it too is a red dwarf, small and dim and old and prone to flaring. Look past it and you find more of the same. A whole run of the closest stars to us turning out to be these little red suns, one after another. The neighborhood a slow ship could ever actually reach is not sprinkled with golden suns like ours. Instead, it is filled, overwhelmingly, with exactly the kind of dim, flaring red star whose planets we have every reason to think are hostile. The nearest stepping stones are the wrong kind of stone. And there are not many stepping stones to choose from in the first place, which is the part that finishes the hope. Draw a sphere around the sun out to a dozen light years or so, about as far as a slow ship could dream of reaching in a survivable time, and inside it there sit only a few dozen star systems all told. A few dozen, and most of those are red dwarfs, and several are burnt-out dead stars, white dwarfs and worse, and a few are wild double stars where stable worlds struggle to form at all. The pool of destinations is not endless. What there is comes to very little, and most of that little is the wrong kind of thing. And the calm sun-like stars, the ones even vaguely resembling our own, are almost absent from the neighborhood. The two nearest stars that are genuinely similar to the sun, steady and yellow and long-lived, are more than 10 light-years off, further than almost anything a slow ship could hope to reach, and we have looked hard at both of them and found nothing we could breathe or drink or stand upon. So the reachable pool is a few dozen systems, nearly all of them red dwarfs and dead stars, and the one type of star we actually know can warm a living world is the rarest thing in reach and still comes up empty when we check it. The stepping stones are few and wrong and lead nowhere. And some of those few stepping stones are not merely useless but actively deadly to draw near. Among the nearest stars are burnt-out ones, white dwarfs, the cooling cinders we met a while ago, and any worlds still circling them were long since scorched down to bare rock when the star died, before being left to freeze in the fading light. Worse still are the wrecks with a spinning corpse at their heart, drowning everything near them in radiation. To cross 10,000 years of dark and arrive at one of those is not to arrive at a poor home. Instead, it is to reach a place that would finish off whatever the crossing had somehow left alive. So the Census does not merely fail to offer a good destination. Here and there it offers destinations that are traps in their own right. Dead stars and scorched worlds that would kill a crew that had beaten every other wall, purely for the crime of arriving. So what about the calm blue planets? The genuine second Earths, wet and warm and shielded, orbiting a steady star at a comfortable distance, with a magnetic field and a real breathable atmosphere, and none of the flaring and none of the tide locking. Do they exist at all? Almost certainly some do, somewhere, in a galaxy this enormous. But here is the fact that closes the door for good. We do not know of a single one within reach, not one confirmed, genuine, Earth-like world with air and liquid water, anywhere near enough that a ship could plausibly cross to it. The nearest true Earth, if such a thing exists, is not known to us and is certainly not close. And reach, remember, is a merciless filter. A slow ship can only ever plausibly aim at the small handful of stars nearest the sun, a few dozen at the very most, across a crossing of many thousands of years. And beyond that handful, the distances and the time simply explode past anything survivable. Inside that tiny nearby handful, the odds that one of them hides a real living world, wet and calm and waiting, are as close to zero as makes no practical difference. The galaxy may well hold a scattering of true Earths. It does not hold one you could ever get to. That is the honest census, laid out plainly. Billions of frozen wanderers, no good to us. Most planets around most stars, tide-locked and flare-blasted, no good to us. The rare, genuine Earths, real but unreachably far, and not one of them even known. The escape story imagines the ship arriving somewhere green and gentle. The inventory says the ship arrives, if it arrives at all, at another dead rock, because dead rocks are very nearly all there is within any distance a ship could cross. There is no new world waiting at the end of the line. There is only more of the same dark, studded here and there with worlds that are frozen or blasted or both at once. And now I want to close a loop I opened a long way back, because by this point in the crossing something has quietly happened to the ship itself, and it is the true heart of what this whole thing is about. Follow the ship out here, thousands of years deep into the dark, and look honestly at what it has become. Its store has run down, its reactor is spent or failing, its outer shell is scarred and pitted and cold. Its crops have thinned, its loops have started to slip, its people are sick or fewer or already gone. It no longer glows with the easy warmth it left home carrying. It drifts, sealed and dimming, through the gap between the stars, holding the last of its heat deep in its core against a cold that is patiently winning. And out there, sliding silently past it in the dark, is a rogue planet, a sealed, frozen, sunless world, holding the last of its own heat deep in its core, drifting through the gap between the stars with no star anywhere to belong to. Look at the two of them set side by side, the ship and the rogue world, and tell me honestly where the difference has gone. Earlier in the crossing you could still say the ship was warm and alive, and the drifter was cold and dead, and that was a real difference and it truly mattered. Out here it has very nearly closed to nothing. The ship that set out counting the dead worlds has become one of them. It is no longer a traveller passing the drifters by. It is one more drifter in the dark, one more cold, sealed, sunless object among the billions, no longer to be told apart from the graveyard it launched to escape. The rogue planets were never merely scenery on the way. They were the honest inventory of the destination, and they were a mirror held up to the ship, and the thing that finally looks back out of that mirror is the ship itself. So the census hands us the very same answer the crossing did, only from the far side of it. There is nowhere to arrive, and the thing built to do the arriving becomes in the very act of crossing exactly the kind of dead cold world it set out to escape, which sounds like the end of it, like a door bolted and barred. And it would be, except that I promised you one honest exception, one real place where this grim picture genuinely leaves a door standing open, and I meant it. So before we count the final answer, I owe you the fairest version of the other side, because there truly is one, and it deserves to be heard properly and in full. Here is the one honest thing standing on the other side, and it is not nothing. We know for a fact that objects can cross the space between the stars and come through it intact. We know it because we have watched it happen 3 separate times now, right here in our own solar system. In recent years, our telescopes have caught 3 visitors sweeping in from outside, objects that never belonged to the sun at all, born around other stars and long ago cast out to wander, that fell through our neighbourhood on their way to somewhere else entirely. The first was a strange elongated splinter of rock, dark and reddish and tumbling, that came and went so fast we barely understood what we were looking at before it was gone. We called it Oumuamua, and it is still argued over. The second was plainly a comet, a chunk of ancient ice from some other star's family, and we watched it trail gas as our sun warmed it in passing, and named it Borisov. The third arrived only very recently, another wanderer from beyond, caught and tracked as it cut in through the solar system and back out into the dark, and given the plain name of the survey that found it. All 3 were moving on open paths that will never ever loop back, the kind of path that marks a thing as merely passing through, never bound to our sun, only crossing its small patch of space on a road that runs between the stars. We named them and watched them for a while and let them go on their way. And what they prove is real and worth stating slowly. Matter makes this crossing all the time. The space between the stars, for all its dust and its gas and its rain of radiation, does not shred every single object that tries to pass through it. These 3 visitors cross light years of the very same dark I have spent this whole time describing as a wall, and they arrived among us in one piece, solid and whole, having survived the exact medium I told you tears things apart. So the dark is crossable. That much is simply not in doubt anymore. Something can travel from the neighbourhood of one star to another and come out the far side intact. And there is nothing in the known laws of physics that flatly forbids a slow, self-contained world moving between the stars in principle. The idea is not magic. The universe plainly permits the crossing to be made. So let me give the fair version its full weight, because a narrator who only ever piles on the bad case is not being honest either, and I would rather lose the tidy conclusion than cheat you here. What is genuinely true is that we cannot rule this out. We cannot stand here and declare a crude crossing flatly impossible, because we hold no law that forbids it, and we have direct proof in hand that the dark itself can be crossed, perhaps far enough into the future, with materials and methods and patience we have not begun to dream of. Some sealed world could make the passage and hold its people alive through the whole of it. I cannot prove to you that it will never happen. Nobody honest can prove that. There is a real door here, and I am not going to pretend it is painted on. But look very closely at exactly what the visitors prove, and exactly what they do not, because the entire weight of the argument sits balanced in that narrow gap. What crossed our solar system was a splinter of rock, and a lump of ancient ice, and another cold dark stone. Dead things, every one. Objects with nothing at all to keep alive, nothing to feed, no air to hold in, no loops to keep closed, no crew to shield from the rain, no store of energy to keep from running down. A rock does not care in the slightest how long the crossing takes. A rock does not breathe, does not starve, does not sicken in the radiation, does not need its reactor to keep turning over for 10,000 years. A rock can drift dead through the dark for 1,000,000 years and arrive at the far end exactly as dead and exactly as intact as it set out. And that is precisely the reason it survives the trip. The crossing is survivable for a dead thing because the dead thing has already given up everything the crossing takes. It has no life left in it for the dark to reach in and end. That is the honest edge of it, laid completely bare. The crossing is proven for a stone, and unproven, wholly and entirely unproven, for anything that lives. Everything we know how to keep alive fails long, long before the distances involved. Every sealed system we have ever built has come apart in months or in a couple of years. Every road across the gap kills the crew in its own particular way. And the destinations, we have just counted them one kind at a time, are dead. So the exception is genuinely real, but it is thin, and it is thin in an exact and important way. The universe permits the crossing. It simply does not appear to permit it for us, or for anything that breathes and needs and hopes with anything we can point to or build or credibly foresee. The door is open. It is only open for the dead. And there is a subtler version of the dream that tries to slip through exactly that gap, and it is worth facing, because it is the cleverest hope there is. Forget keeping grown people alive the whole way, the dream says. Send the crossing as something closer to a seed. Send frozen cells, sleeping and lifeless for the long dark machines to tend them, and only wake life at the very far end once a world is reached. It is ingenious, and it dodges the problem of feeding and breathing and aging across 10,000 years, because for almost all of that time nothing aboard is truly alive to suffer. But walk it through and it runs straight back into the same two facts that sank everything else. The machines that must run flawlessly across 10,000 years of radiation and entropy are exactly the kind of thing we just watched fail. And even if the seed arrived perfectly, arrived where? We already counted the destinations. There is no warm, wet world at the end for the seed to open onto. The cleverest version of the escape still has to land somewhere, and there is nowhere for it to land. And even if you grant it everything, even a perfect ship and a perfect crossing and a flawless arrival, the deepest problem is still standing there untouched. Say the impossible all comes off. The ship holds for 10,000 years, the crew endures, the aim is true, the brakes fire, and the vessel settles at last into orbit around the nearest world we know of. It settles around Proxima b or around one of the Trappist worlds because those are what is actually there. And the crew look down at a tidally locked rock, half of it baked under a flaring red coal and half of it frozen in unending dark, its air very likely long since stripped away. They crossed an ocean of dark and time and radiation, spent 100 generations to get there, and arrived at the same kind of hostile stone we saw at the very beginning. The exception lets a dead object survive the trip. It does nothing at all about the fact that the trip, even completed perfectly, ends nowhere worth ending. And that hands us the one question I am not going to answer for you, because it is not a question of fact at all. It is a question of what any of this is worth, and honest, thoughtful people land in genuinely different places on it. Here it is as plainly as I can put it. Suppose you could launch a ship, knowing full well it would never arrive, knowing the crew and their children and their children's children would live and die in the dark and reach nothing, knowing the ship would end as one more cold drifter among all the rest. Not a lifeboat carrying survivors to a new shore. A sealed world that carries people onward for a while, for a few more centuries of living and thinking and loving and arguing in the dark, before it too goes cold and quiet. Is that worth doing? Is carrying humanity onward for a few more generations, with no destination at all at the end of it, a thing worth launching, a last defiant act of a dying species that refuses to simply stop? Or is it a cruelty past bearing, condemning thousands of unborn people to be born inside a sealed tomb for the sake of a gesture their ancestors found comforting? I have my own lean on it, and I will not hide from you that I have one. But I think this particular question is genuinely yours to sit with, not mine to close, and I would far rather leave it open and honest than seal it up with a false answer. Hold it. It is the real weight underneath everything else we have said. Because it brings us back around, at last, to the only question this whole thing was ever really about. Set the meaning of it aside for one moment and come back to the plain physical fact. How long? If the last humans sealed themselves inside a ship and set out into the dark, how long, honestly, could they last? Let us put every single piece of it together now and answer that, straight, with no comfort added and none taken away. So, how long? Here is the honest answer, assembled out of everything we have looked at, with nothing left out to make it sit any easier. The last of us could last a long time out there. I want to say that first and say it clearly, because it is true, and it is the part the grim version of the story too often skips over. A well-built ship, launched with a full store of power and a genuinely good recycling system and a disciplined, willing crew, would not fail on the first day, or in the first year, or even across the first century. It could plausibly run for a long stretch, generations deep, hundreds of years, perhaps considerably longer still if the engineering were extraordinary and the luck held all the way. People would be born aboard, live entire lives aboard, love and quarrel and raise children and grow old and die aboard, and for a good long while the ship would carry human minds and human voices onward through the dark. That is real, and it is worth honouring rather than sneering at. Long is genuinely on the table. But forever is not, and by now we know exactly why, from 4 directions at once, and each one alone would have been enough. The sealed loops that keep the air breathable and the water clean and the food growing have never once in the whole of our experience held for even a single year without coming apart, and the ship needs them to hold for tens of thousands. The second law of thermodynamics guarantees that a closed ship on a finite store far from any star must run down in the end no matter how flawless its machinery, because usable energy only ever drains away and never once refills. The crossing to anywhere real takes tens of thousands of years by the only road slow enough to survive the medium, and by the fast road that might have beaten the clock. The dust and the gas simply tear the ship to pieces, and the whole way across, at every speed on the dial, the rain of particles works patiently on the crew, seeding cancer and clouding minds and breaking bodies and stealing away the power to bear healthy children, until the people meant to carry humanity onward can no longer carry even themselves. Any one of those 4 alone would be enough to end it. All 4 together do not leave so much as a crack of daylight. So the answer to forever is no. Not a soft no from some failure of nerve or want of trying, and not a hopeful maybe if only we were clever enough. What it is a hard no, written into the plumbing and the physics and the distances and the rain all at once, 4 separate walls all handing down the same verdict. Long, yes. Forever, no. But I want to press on the word lasting itself for a moment, because I think it hides the real answer even after the number is settled. There is a difference between a ship that lasts and a people that lives, and the escape story blurs the two together on purpose. A ship can keep running long after the life inside it has stopped being anything you would wish on anyone. Picture, not the launch, with its full stores and its hopeful crew, but the long middle and the long end. Generation after generation born into a shrinking, souring, failing thing, each one inheriting a little less than the last, a little more broken machinery, a little thinner air, a little more sickness, a little less knowledge of how any of it works and why they are even out there. The ship might well go on carrying human beings for centuries after it has stopped being a place a human being would choose to be born. So even the long that is genuinely on offer is not the bright long of the story, the hopeful crossing to a new dawn. What is actually on offer is a slow guttering, a light burning down, people living smaller and sicker lives in a dimming vessel for as long as the machinery can be kept limping. That is what lasting really means out there. Surviving is not the same as living, and the ship is built at best only for the first. And here is the part that I think matters even more than the timing, the part that quietly changes what the whole question was ever asking. The ship does not arrive. There is no new world waiting at the end of it. We counted them, carefully, one kind at a time, every sort of world within any possible reach, and they came up frozen wanderers and flare-blasted rocks and a bare scattering of true Earths far too distant to be known, let alone reached. So the ship does not fail on the doorstep of a green shore it very nearly made. It fails out in the deep dark, nowhere near anywhere at all, in a gap between the stars with no destination on any side of it. And in failing there, it becomes the very thing it spent all those long centuries passing by. Its store runs down, and its warmth leaks away into the cold, and its lights go out one by one, and what is left at the end is a sealed, cold, sunless object drifting between the stars, holding the last of its heat deep in its core, belonging to no star anywhere, one more drifter in the dark. Impossible to tell from the outside, from any of the billions of dead frozen worlds it spent those centuries crossing to escape. There is a hard irony sitting in that, and it is worth naming plainly. The only vessel that has ever actually carried life across the ages, across billions of years, is a whole living world warmed by a star. Not a sealed can running on packed supplies, but a planet, with an ocean and an atmosphere and a molten iron heart throwing up a shield, endlessly refilled by the sunlight pouring down for free. That is the one kind of ship that has ever worked, and we are already aboard it. The dream of the Great Escape vessel is the dream of shrinking all of that, the whole self-renewing machinery of a living world, down into a sealed box we carry with us into the dark. And the lesson of every wall we have hit is that it does not shrink. A world works because it is a world, open to its star, large enough to bury its own mistakes. A box in the dark is closed, and finite, and alone, and the box always loses. Go back to the very beginning now, all the way back to the planet I opened with. A world about the size of Earth, falling through the dark with no sun to fall around, its surface hundreds of degrees below freezing, alone longer than our species has had a name. I showed it to you then as a curiosity, a strange, lonely thing out there in the galaxy, one of a countless billion. I want you to look at it again now because you know at last what it is. That is not just some far-off rogue world I happen to open on, that is what the ship becomes. That frozen sunless drifter, circling nothing, holding its last warmth in its heart against the cold, is the end state of the Great Escape, the last human's vessel 1,000 generations on, gone cold and quiet and utterly indistinguishable from all the rest. We opened, without either of us knowing it, on the ship's grave. The very first thing I ever showed you tonight was the ending. And I understand completely why the other story, the hopeful one, is the one we tell. It is a beautiful thought, the arc in the dark, the last of us sailing on toward a new dawn while the old world dies behind. It says we are the kind of creature that does not simply accept an ending, that we can always run one more step ahead of the dark. I feel the pull of it as strongly as anyone, but I have come to think that the hopeful version is a way of not looking at something, and that the true version, hard as it is, respects us more because it treats us as grown enough to hear it. The dark is not a road with a far side we have not reached yet. For anything that lives, so far as everything we know can tell us, it is a wall, and the ship does not get through it, and there is nothing on the other side to get to. I have to mark one last honest edge, because I have held to that this whole way through, and I will not drop it at the finish line. The exact number of years is genuinely unknowable. I cannot tell you whether a real ship would last 400 years or 4,000, because it turns on engineering we have never built and luck we have no way to model. and anyone who hands you a firm figure is only guessing while dressed up as certain. But the two things that actually matter are not in any doubt, and no amount of unknown detail can shift them. Whatever the number turns out to be, it is finite. And whatever the number turns out to be, it arrives nowhere. The ship runs, and then the ship stops, and it stops out in the dark with no shore anywhere in sight, having reached nothing at all. And that is not the failure of one particular ship, badly built or unlucky in its crossing. What it is the shape of the thing itself, the shape the physics gives it, no matter who builds it, or how well, or with what hope. I keep coming back to that first planet, the one falling through the dark with no sun to fall around. When I started reading for this, I thought the ship was the way out. I do not think that anymore. The ship is not an escape from what happened to Earth. Instead, it is the same ending, carried out into the dark and made smaller and quieter and slower. Everything a world does for you for free, the ship has to do by hand, with no sun to run on and nothing outside to draw from. Go slowly, and the machine wears down before anywhere comes into reach. Go quickly, and the space you thought was empty turns solid against the hull. And at the far end, in almost every direction, there is no new world waiting, only more of the frozen, sunless ones that left home first. So here is where I have landed. The last humans could last a long time, long enough to forget the sky they came from, but not forever, and not to an arrival. The honest picture is a lit and running ship, going colder by degrees, becoming over time just one more drifter in the dark, no different from the dead worlds it passes. I do not find that hopeless exactly. I find it clarifying. Whatever we are going to be it here, around this star, or not at all. That is the truth I think this points to, and I would rather face it than the comfortable version. If you would like more nights like this one, the subscribe button is what keeps them coming.